Detailed expansion. 1. Introduction. Supernovae are among the most spectacular events in the universe, marking the explosive death of stars. These events have profound implications for understanding stellar evolution, nucleosynthesis, and the dynamics of galaxies. The observation of supernovae has a rich history, spanning from ancient times to the present day, reflecting the evolving understanding of the cosmos. 2. Ancient observations. Early records and cultural impact. The earliest recorded supernova observation comes from Chinese astronomers in 185 AD, known as SN 185. This event was meticulously documented in the Book of Later Han, describing a guest star that shone brightly for several months. Such records provide crucial historical data, offering insights into ancient astronomical knowledge and methodologies. Other ancient cultures, including the Romans, Greeks, and Native Americans, also recorded celestial phenomena, though interpretations varied. These observations were often tied to mythological and religious beliefs, reflecting the cultural context of the time. Astronomical knowledge and instruments. Ancient civilizations possessed varying levels of astronomical knowledge, often relying on naked-eye observations and rudimentary instruments like armillary spheres and astrolabes. These tools were primarily used for tracking celestial objects, and while limited, they allowed for significant discoveries and accurate record-keeping. Interpretation and mythology. Supernovae were frequently interpreted through the lens of mythology and religion. In China, guest stars were considered omens, often associated with significant terrestrial events. Similarly, other cultures imbued these celestial events with spiritual or prophetic significance, illustrating the intertwining of astronomy and cultural belief systems. 3. Medieval observations. The Middle Ages and astronomical observations. The Middle Ages saw continued documentation of supernovae, albeit with a stronger emphasis on astrological interpretations. Notable supernovae from this period include SN 1006 and SN 1054, both extensively recorded by astronomers in China, Japan, and the Islamic world. SN 1006, Global Observations and Impact. SN 1006, observed in 1006 AD, was the brightest supernova recorded in history. Chinese astronomers described it as appearing several times brighter than Venus, while observers in Egypt, Iraq, and Italy also documented the event. This supernova's brightness and visibility had a profound impact, influencing both scientific and astrological thought across cultures. SN 1054, the creation of the Crab Nebula. SN 1054 led to the creation of the Crab Nebula, a supernova remnant first recorded by Chinese and Japanese astronomers. This event is one of the best-studied supernovae, providing extensive data for modern astrophysical research. Islamic astronomers and their contributions. Islamic astronomers made significant contributions to the documentation and understanding of supernovae. Scholars such as Ibn Sina, Avicenna, and Al-Biruni recorded detailed observations, which later influenced European astronomy during the Renaissance. European records and chronicles. In Europe, supernovae were often chronicled by monks and scholars, with varying degrees of accuracy. These records, while sometimes inconsistent, provide valuable historical context and demonstrate the widespread interest in celestial phenomena. 4. Renaissance to early modern period. The Renaissance revival of astronomy. The Renaissance marked a revival in astronomical studies, driven by figures like Tycho Brahe and Johannes Kepler. This period saw significant advancements in observational techniques and theoretical models. Tycho Brahe and SN 1572. Tycho Brahe's observation of SN 1572 challenged the prevailing Aristotelian view of an unchanging cosmos. His meticulous records and parallax measurements demonstrated that supernovae were far beyond the Earth's atmosphere, contributing to the shift towards a heliocentric model. Johannes Kepler and SN 1604. Kepler's observation of SN 1604, also known as Kepler's supernova, further solidified the understanding of supernovae as distant celestial events. His work built on Brahe's observations and advanced the field of supernova studies. Advances in telescopic technology. The invention of the telescope in the early 17th century revolutionized astronomy. Galileo's telescopic observations laid the groundwork for more detailed studies of supernovae and other celestial objects. Impact on scientific thought. The observations of supernovae during this period had a profound impact on scientific thought, challenging long-held beliefs and paving the way for the development of modern astronomy. 5. Modern observations, 19th to early 20th century. Technological advancements and discoveries. The 19th and early 20th centuries saw significant technological advancements, including the development of photographic plates and spectroscopy. These innovations allowed astronomers to capture and analyze supernovae with unprecedented precision. First observations in other galaxies, S Andromedae. In 1885, S Andromedae became the first supernova observed in another galaxy, the Andromeda Galaxy. This discovery expanded the understanding of supernovae and their occurrence beyond the Milky Way. Classification of supernovae. In the early 20th century, astronomers began classifying supernovae based on their spectral characteristics. This led to the identification of two primary types, Type 1 and Type 2, each with distinct progenitor stars and explosion mechanisms. Early theories and models. Early theories on supernovae focused on the collapse of massive stars and the thermonuclear explosion of white dwarfs. These models laid the foundation for modern astrophysical research. 6. Late 20th century developments. Discovery and observation techniques. The latter half of the 20th century saw the development of advanced observation techniques, including radio and X-ray astronomy. These methods provided new insights into the behavior and aftermath of supernovae. Notable supernovae: SN 1987A. Supernova 1987A, located in the Large Magellanic Cloud, was the closest observed supernova since Kepler's SN 1604. It provided a wealth of data due to the availability of modern observational tools, significantly advancing the understanding of supernova mechanics. Evolution of theoretical models. Theoretical models of supernovae evolved with the advent of computer simulations and improved understanding of stellar evolution. These models helped explain the complex processes leading to and following supernova explosions. Role of supernovae in understanding the universe. Supernovae play a crucial role in cosmology, particularly in the study of dark energy and the expansion of the universe. Observations of distant supernovae have been instrumental in discovering the accelerating expansion of the cosmos. 7. Contemporary observations and research. Space-based observatories, Hubble, Chandra, etc. Space-based observatories like the Hubble Space Telescope and the Chandra X-ray Observatory have revolutionized the study of supernovae. These instruments provide high-resolution images and spectra, enabling detailed analysis of supernova remnants and progenitor stars. Ground-based telescopes, Very Large Telescope, etc. Ground-based telescopes, such as those in the Very Large Telescope (VLT) array, continue to contribute significantly to supernova research. Advanced adaptive optics. 1. Introduction. Definition and importance of supernovae. Brief overview of historical observation. Structure of the paper. 2. Ancient observations. Early records and cultural impact. Chinese records, SN 185. Other ancient cultures. Astronomical knowledge and instruments. Interpretation and mythology. 3. Medieval observations. The Middle Ages and astronomical observations. SN 1006. Global observations and impact. SN 1054. The creation of the Crab Nebula. Islamic astronomers and their contributions. European records and chronicles. 4. Renaissance to early modern period. The Renaissance revival of astronomy. Tycho Brahe and SN 1572. Johannes Kepler and SN 1604. Advances in telescopic technology. Impact on scientific thought. 5. Modern observations, 19th to early 20th century. Technological advancements and discoveries. First observations in other galaxies, S Andromedae. Classification of supernovae. Early theories and models. 6. Late 20th century developments. Discovery and observation techniques. Notable supernovae. SN 1987A. Evolution of theoretical models. Role of supernovae in understanding the universe. 7. Contemporary observations and research. Space-based observatories, Hubble, Chandra, etc. Ground-based telescopes, Very Large Telescope, etc. Supernova surveys and catalogs. Contributions to cosmology and dark energy research. 8. Case studies of significant supernovae. Detailed analysis of key supernovae. SN 185, SN 1006, SN 1054,
1054 ईस्वी में एक और सुपरनोवा ने आकाश को रोशन किया। इस बार दिन के समय भी दिखाई दिया। चीनी और अरब खगोलविदों ने इस खगोलीय घटना को रिकॉर्ड किया, इसकी असाधारण चमक और अवधि को नोट किया। इस सुपरनोवा के अवशेष, जिसे अब क्रैब नेबुला के रूप में जाना जाता है, आज भी दिखाई देता है, जो इन तारकीय विस्फोटों की शक्ति का प्रमाण है। सुपरनोवा को समझने के लिए हमें पहले सितारों को समझना होगा। सितारे गर्म गैस के विशाल गोले होते हैं, जिनमें ज्यादातर हाइड्रोजन और हीलियम